In problem number 6 here, we are cutting some diamonds. We've got 423 diamonds total. Some of those had major flaws in them, some had minor flaws, some had both, some had neither. Here's the breakdown. So this 12 means that they had a major flaw and a minor flaw. This 18, they had a major flaw but no minor flaw. 42, no major flaws, but they did have minor flaws. And 351, no major flaws, no minor flaws. So that'd be no flaws. And so we want to know, find the probability that a randomly chosen diamond has a major flaw. So we can represent that like this, probability of a major flaw. Well, the 12 here had a major flaw and a minor. 18 had a major flaw but no minor. So we want to add those together. So why don't we go ahead and do our row totals and column totals here, so we'll have those all figured. So 12 and 18, do a total here and a total here. So 12 and 18 is 30. 42 and 351 is 393. Add these guys vertically, so that column total is 54. And then 351 and 18 is 369. And if you add these or add these, you get your 423, which is right here. So now, probability of a major flaw are going to be the number that have a major flaw, 30, divided by the total. So this will be 30 out of 423 desired out of total outcomes. It's a randomly chosen diamond, so it's equally likely that we would choose any of those 423. So 30 divided by 423 is 0.0709. So 7.09%. Find the probability a randomly chosen diamond has a minor flaw. So minor flaws, total minor flaws are 54. So probability of a minor flaw is desired outcomes, 54 minor flaws out of total outcomes, 423 diamonds to choose from. 54 divided by the 423 is 0.1277. So 12.77% chance. Find the probability a randomly chosen diamond has a flaw. So that's saying major or minor. So this is asking what's the probability of major or minor flaw? Well, this is a union rule because it's got or an addition rule. So we take the two separate probabilities, probability of a major plus probability of minor. So we add those, and then we subtract out the overlap. So minus probability of major and minor. So major flaw we already did, 30 out of 423. Plus probability of a minor, that's 54 out of 423. And then we want to subtract out the overlap. So major and minor flaw. So major flaw here, minor flaw here. There are 12 that had major and minor. So there's 12 in the overlap. So this would be minus 12 out of 423. Those all have a common denominator, so we do 30 plus 54 minus 12. So 30 plus 54 minus 12 is 72. Divide that by our 423, 0.1702. So this is 72 out of 423. 0.1702, so 17.02%. Probability a randomly chosen diamond has no major flaw. So that no is like a not. That's complement rule. So probability of no major flaw is 1 minus probability there is a major flaw. So this will be 1 minus probability of a major flaw right there. 30 over 423, which is going to be 1 minus the 0.0709. 1 minus 30 over 423, 9291. So 92.91% chance that there's no major flaw.